All right, this is the video for section 11-3, which deals with the surface areas and the lateral areas of pyramids and cones. After 11-2, you should have gotten kind of used to some of the terminology, lateral area and surface area. Cones can be a little bit more difficult to draw. Basically, the best way to go is to start with the base. And you won't necessarily need to draw these. And this is going to be the pyramid. That would be considered either a square or rectangular pyramid because the base is that. Typically, you'll go up on the top and then draw the extensions to all four corners. So there's a pyramid. I'm actually going to erase this one because I just realized I need it to be a little bit flatter to show you the part that I need. So we're going to go a little bit more at an angle, a little bit flatter, like so. We'll draw our point up here, do one down there, one here, and one here. Don't necessarily worry about being able to draw these. It's not that big of a deal. The key part, however, is the triangle that is in the middle of this. I'm going to use blue to show this right here. And down here, that's a right angle right there. And then that right there. That blue triangle becomes key. We need to label a few things here. Okay. So let me switch back to a different color. Let's call this part the height, or the H. Doesn't have as much importance in the actual formula. This part over here is called the slant height. This becomes very important. Slant height there, that's a cursive L. The regular height is a lowercase h. Okay. And then the base is going to be down here. In this case, it's either a square or rectangular pyramid. So we've got all those so that we can go through and list the formula for lateral area and surface area. The lateral area is the triangular faces that come up from it. So you can see that there's 1, 2, 3, 4 triangular faces. So the lateral area is going to be 1/2 the perimeter of the base times the slant height. The surface area is going to be the same, 1/2 the perimeter of the base times the slant height, plus you have to add a single base. So unlike a prism, which adds plus 2b, this one only adds plus b. Now, keep in mind, this base here has to be substituted in with whatever the actual base area calculation would be. So in this case, I would typically take off that b and do plus length times width or base times height, because we have a rectangular base. So there's the formulas. Let's go ahead and do a problem so you can see it. Let me erase all of this stuff here. Don't be forgetting, however, to take those formulas and put them in your cheat sheet for a test and also for homework. Having all these formulas available will be very helpful. All right. So problem number 1, we've got a hexagonal base. So you got to do a hexagon here. And the back side of the hexagon is going to be all hidden. So there's our hexagonal base. I'll just pick a spot up here, and that's going to be the top of the pyramid. And you just connect all of the other parts. there. So there's at least a decent drawing. It's not perfect, but it'll work. Now we know that we have 6 inches down here. And then we've got a spot there in the center. And I'm going to switch colors again. This little spot here, you'll remember, this is going to be our apothem in there, which we're going to need. And we're told that the apothem is 3 radical 3 inches. So this apothem in there is 3 radical 3. And then we've got a slant height. I'll switch back to blue. The slant height is going to come through here. It can either be solid or dashed. And our slant height is going to be, in this particular problem, 9 inches. So that is 9 inches. Okay, so the surface area involves both the lateral area and the surface area. So we'll just focus on the surface area. It's 1/2 the perimeter of the base times the slant height plus the area of the base, which is 1/2 the perimeter times the apothem. So all we've got to do is go in and fill in the figures that we've been given. So our surface area is going to be 1/2. The perimeter is a hexagonal base, so 6 sides times 6 per side, because it's 6 inches per side, is 1/2 of 36, times my slant height of 9. But then we have to do 1/2 that same perimeter, 36, times the apothem, I'll do it underneath here, of 3 radical 3. Now, this problem's easy because everything's been given to us. You will not always have everything given to you. You're going to have to struggle to find some of those things at times. But we end up with the surface area being 1/2 of 36 is going to be 18, and 18 times 9 is equal to 162. Plus 1/2 of 36 is 18, and 18 times 3 radical 3 is 54 radical 3. So we'll multiply 54 times the square root of 3 and add 162 to it. Let me get the square root of 3 of 54. And I'm getting 255, approximately 255. Whoa, that 5 didn't work real well. 0.5. And this is inches squared. All right, so that's how you would go about finding the lateral and surface area of that pyramid. Now, there's other practice problems that are available in the chapter to help, so I want to stop here and switch over to a cone. Just like a prism has circular bases and becomes a cylinder, a pyramid has circular bases and becomes a cone. Because there's only one base in a pyramid, if that base is a circle, then it's a cone, and it looks just like an ice cream cone. They're not even all that hard to draw. And the math is very similar to a pyramid, just with a circular base. So here's our circular base. I'm not going to be able to see the backside because it's going to go up to a cone like that. There's our cone. Key pieces of it. You're going to have your radius. Actually, I'm going to need a bigger one to be able to label this, and I'll try to label it with different colors. So let's get a bigger circle here. So there's our circular base. Goes up to a peak here becomes a cone. You don't see the back of the cone because of that. Switch colors, and let's identify all the key pieces. Whoa, accidentally hit my hand on there. The radius goes from the center to the side. So that right there is the radius. You'll need that in some calculations. The base is just the circular base. The slant height is this little piece along the side of the cone. And then you've got the formulas. Switch back to red here. The lateral area of a cone, since it has a base that's a circle, is going to have pi. It's 1/2 2 pi r, or 2 pi rl. But we usually leave off the 1/2 because what's 1/2 of 2? Just 1. And so we can say that the lateral area is just pi r l. Again, the L is a cursive slant height L. The surface area is the lateral area, which is pi rl. But then you have to add the area of the base, which in this case, your base is a circle, so that's just pi r squared. So there's your two formulas. If you're given one with a slant height of 25 and a radius of, goodness, I'm having trouble seeing it. Looks like 15 for the radius here. That's a 15. Then to get the surface area, you would just do pi times 15 times the slant height of 25 plus pi times your radius of 15 squared. 15 times 25 is equal to 375 pi here, plus 225 pi there. And so I believe that that is 600 pi, either inches or centimeters. I think this one's centimeters squared. I'd have to check it. Yeah, it's centimeters squared. This is problem number 3 in the book. And then you got to check again in Math Excel and check and see if it says, please leave this in terms of pi, or please to the nearest tenth, or whatever you need. All right, we're just under the 15 minutes. So there's your 2, or actually 4 new formulas. The lateral and surface area of pyramids and cones. They're very similar to each other. Hopefully this will help you get set up. But you may need to spend a little bit of time going through the book and looking at a few extra examples. If you're struggling with it at all, please feel free to contact me and come in for one of those tutoring sessions in the afternoon. Or on Thursday or Friday, I'll also offer tutoring in the morning, pretty much by appointment if you've got some free time. Good luck with it, guys. Talk to you soon.